Hello guys, welcome to another session of Mate Math. I hope you guys are doing good. Today in this video, we are going to look at how we can solve this integral problem here with U substitution approach. Well, you can pause the video and try. Now that you know the approach that we are going to use. Or, let's get started. We are going to do substitution right from here. We are going to let u be equal to square root of 2x. You can also let u be equal to 2x, or maybe this, then you solve. But we are letting u be equal to square root of 2x. Substitution. We are going to square both sides. When we square this, it will give us 2x. When we square this, it will give us u squared. We are going to differentiate this equation. When we differentiate this, we are going to get 2u du. When we differentiate this, we are going to get 2 dx. We are going to divide both sides by 2. And that will give us dx is equal to u du. Now that we are entering the u world, everything has to be in the u world. So we have to find what is going to replace x in the u world. So from this equation, we're just going to divide this one by 2 and then divide this one also by 2, and that will give us u squared over 2. X is equal to u squared over 2. When we enter the u world, we will replace x with u squared over 2. Let's enter the u world. When we open this bracket, we are going to get u raised to the power 4, and then here 2 raised to the power 2 will give us 4. U times u will give us u squared. These two here, on top here, the coefficient of this u is 1. So that 1 and this 2 will be 1 out of 2. And we will bring that 1 out of 2 at the back here. When we simplify this one, we are going to get u raised to the power 4 plus 4 all over 4. This 4 will come and multiply u squared, and that will give us 4u squared. Four will come out here, and it will multiply 1 out of 2, and that will give us 2. We are going to rewrite this one using symmetric function. We will write this one as 2 raised to the power 2 so that it will suit the symmetric function approach very well. From symmetric function, when we have a squared plus b squared, it is equal to a plus b all squared minus 2ab. We are going to rewrite this one using what I just said. U squared times 2 give us 2u, times 2 give us 4, 4u squared. We are going to rewrite this one using difference of two squares. When we have something like a squared plus minus b squared and we want to factorize it from difference of two squares, it is going to be a plus b multiplied by a minus b. So we are going to rewrite this one or factorize this one using difference of two squares. But we will first rewrite 4u squared to suit the difference of two squares method very well. Still, it is not easy to integrate. When we have something like a over b plus c over d, then we want to write this one, we want to write it as a single fraction. It will be dA plus BC all over dB. It becomes a single fraction like this, as this one is what, as you are seeing here. So the question is, what if I want to reverse from this state to the original state? How are we going to do that? Normally, if you want to reverse any single fraction, we use what we call partial fraction approach. But in this video, we are not going to use the partial fraction approach to reverse this fraction. We are going to do what we call inspection to reverse this fraction. Sometimes you can do it that way and it will work out for you. Let's write this one as 1 over u squared plus 2u plus 2 plus 1 over u squared minus 2u plus 2. Let's sum it up. Summing it up will give us this one plus this all over this one. So u squared plus u squared will give us what? 2u squared minus 2u plus 2u will be 0. This plus this will give us what? 4. So when we sum it up, you are going to get 2u squared plus 4. We didn't get something like this. We didn't get something like this. So this one won't work. What about subtracting? let's subtract and see if we get something like this. You know, the denominator will always be in this form. So let's focus on the numerator. We are subtracting. This was the first fraction and this one is the second fraction. So this one minus this minus u plus this plus u squared will be what? 0. Minus 2u minus 2u give us minus 4u. Minus 2 plus 2 give us what? 0. This one is going to give us minus 4u all over this one. You see, we've gotten it to be negative, but this one here is not negative. Well, let's try the subtraction once more. This time we are going to write this one as the first fraction and also this one as well, the second fraction. Then we subtract. This one is the same denominator because multiplication is commutative. So we are subtracting this one from this because this one is the first fraction and this one is the second fraction. So u squared minus u squared will give us 0. 2u minus 2u will be plus, and that will give us 4u. 2 minus 2 will be 0. This one, after subtracting, we had 4u. It is what? Positive. Good. Good. On top here is what? U squared. This one means that if we write the fractions as u over 4 on each of them, then we simplify. We factorize u over 4 out, and then we subtract these two fractions. We subtract this one from this. We are going to get 4u, and we multiply that 4u by u over 4. We are going to get u squared, and at the end of the day we get this one back. So we are going to write this one as this one. You just pause the video and then simplify this fraction. This one is the same denominator here. This times this. This times this. Factor out the u over 4 out and find out if you are not going to get this one back. Alright, we are going to split this one into two different integrals. So by splitting, this is what we are going to get by splitting. We are going to solve this one separately and also solve this one separately. We will call this one A and also call this one B. After getting answer for A, and after getting answer for B, we just put the two answers together. So integrating A, this one is A, integrating A, U over 4 is the same thing as U times 1 out of 4. So we will bring 1 out of 4 at the back and it will multiply 2, and that will give us 1 out of 2. What are we going to do from here? Here we are going to subtract 1 from this U and then add 1 back. Why? Because when we differentiate this denominator here, we are going to get 2u minus 2. When we factorize 2u minus 2, we are going to get 2 into bracket u minus 1. And from that, we can do substitution to eliminate this u here, and then we get answer for this one. So let's subtract 1 from u and add 1. We are going to rewrite this one as 2 like fractions. This over this one plus this over this. We are going to split once again because I want to avoid what? Confusion. Let's split. We are going to solve this one separately and also solve this one separately. After that, we add the two answers for this one together, and that will be the answer to u over u squared minus 2u plus 2. We will call this one y, and then we will call this one t. Starting with y. We are going to do substitution. When we differentiate this, we will get what is here. Then we do cancellation. We are letting k be equal to this. When we differentiate this, we are going to get 2u minus 2 du, and this one will give us the k. Let's factorize this one. We are going to divide both sides by this one. And that is going to give us 1 over 2 into bracket u minus 1 dk is equal to the u. So when we see the u in the k word, we will put this one there. This will cancel out with this 1 times 1 will give us 1, and then 2 times this one will give us 2k. We can bring the 1 out of 2 outside, and that is going to give us 1 out of 4 integral of 1 over k dk. Please, this one is dk, not du. Now, this one is very simple to solve. This one will give us natural log absolute value of what? K. But k is equal to u squared minus 2u plus 2. We are going to replace k with this one. This is the answer for y. let's move on to t. When we differentiate this, what we are going to get will be the same thing as what is here. So substitution will not work. What are we going to do then? Well, we can factorize this expression here. But before we factorize, we can write 2 as 1 plus 1. When we factorize this one, it won't work. But when we write 2 as 1 plus 1, then factorize, I think that one will work, because we can write 2u as u minus u. When we consider these three, the factorization will work. This 2u can be written as minus u minus u. I'm going to bracket this, and also this and this. U is common here, so u will come out, and it will be left with u minus 1. U plus 1 will come out, and here will be left with u minus 1. I'm going to bracket this and this, then we multiply by one of this, either this or that. We are going to write this one as u minus 1 all squared. Good. This one is more easy to integrate than the original one, because when we do substitution, maybe let p be equal to this, the u will be equal to the p, and here will be p squared, and we all know the answer to integral of this nature, 1 over something squared plus 1. The answer is tangent inverse of something. So the answer to this integral is tangent inverse of u minus 1. We have gotten answers for each of the two that we decided to solve separately. So what we are going to do here is that we are going to add the two answers together so that we can get the answer for the original one. The original one is what? A. And from that A we had Y and then T. So if you want to get A, we have to add Y and then T. So A is equal to Y plus T. Because I'm not going back, I'm just going to write what is A for you. So if any of you has forgotten, you immediately remember what we called what A from the during our what workings. The answer to A is this one here. This is A, and the answer to it is what? This one here. We will not add the plus C because we are not done yet. Before we can add the plus C, we have to get the whole answer for the main question. It has left with 1, so we can add the plus C. Now let's continue. Integrating B. How we solve integral A is going to be the same thing as how we are going to solve integral B, just that B, the denominator is what? Positive, and then A, the denominator, we were having what? A negative in it. Okay, it's the same procedure. We are going to bring this 4 here, and it will multiply 2, and that will give us 1 out of 2. We are going to add and subtract 1 from U. We are going to write this one as a single fraction. Sorry, we are going to write this one as two like fractions. This one all over this minus this one all over this. We are going to split. We are going to split. We are going to solve them separately. We will call this one J and call this one R. After that, we will put our two answers together. We are going to start with this one, which is what? J. We are going to do substitution. We are going to let W be equal to this one. When we differentiate this, we are going to get the W is equal to 2U plus 2du. We are going to factorize this. Let's divide both sides by this one. In the W world, we will replace the U with 1 over 2 into bracket U plus 1 the W. This will cancel out with this. This half here, 1 over 2 will come out and it will multiply 1 out of 2, and that will give us 1 out of 4. And here we'll be left with 1 over W. This one will give us natural log absolute value of W. But W is equal to U squared plus 2U plus 2. So we are going to replace W with this one. There is the answer for integral J. Now let's move on to R. I hope you all know what we are going to do here. Factorization. we will write these 2 as 1 plus 1, and then write 2u as u plus u. Let's write this one as u plus u. We are going to bracket this and this, and also this and that. U is common here, so u will come out and it will be left with u plus 1. When you come here, it's the same thing as u plus 1, but still 1 will come out. I'm going to bracket this and this, then we multiply by either this or that. We will write this one as u plus 1 all squared. We all now know the answer to this integral. That is tangent inverse of u plus 1. That is the answer to integral r. But we know that b is equal to j minus r. J minus r. I'm going to do the same thing here. Maybe you have forgotten your b, so I'm just going to put integral for b back here. This one is the answer to integral b, which is this one. We are going to put the two answers together. But the original integral is equal to a plus b. And remember, from the where we gave them the names a and b, the b part was negative, but we didn't include it when we were working the answer for b part out. So let's add the answer for A and B together. The original integral, as we all know, when you are solving integral problem which require a lot of workings, we normally let the original one be equal to I. That is what we normally do. Yeah, but because the workings are very lengthy here, and because of how I'm working it out or presenting it for you guys, I decided to not to bring the I but maintain the original hot one. Okay, yours, you can just let the original one be equal to I and then you are good to go. This one is equal to A minus B. What is A and then what is B? This is A and then this is B. I'm just reminding you of what we called A and then B during our hot workings. We know the answer to this one. We also know the answer to this one. So let's put them, or let's replace them here. This one is in a bracket because A and B were what? A and B is what? Subtracting. So we are going to open this bracket by multiplying this minus through. When we multiply this minus 1 by this one, the whole of this one will be negative, and minus 1 times the whole of this one will be all positive. So when we open the bracket, this one will be negative and then this one will be all positive. This one here is negative, and then this one here is positive. So is it going to cancel out? The answer is no. Why? Because what is here is not the same thing as what is here. If what is here is the same thing as what is here, then it cancel out. From the laws of logarithm, this one and then this one can be written as 1 out of 4 natural log absolute value of this one is positive, so this one will be on the numerator's position. u squared minus 2u plus 2 over u squared plus 2u plus 2. Why? Because from the laws of logarithm, log a over b is equal to log a minus b. When we reverse log a minus log b, I'm just going to get log a over b. When we apply the same thing here, that is what we are going to get for this and then that. This one is positive and also this one is well positive. Can it be added? The answer is no. Why? Because here is positive and here is negative. This one and this one is not or are not the same. Therefore, we cannot add or subtract. Then, what should we do, or what will we do? We will just write it as it is. Just write this one plus this one, or this one plus this one, and that's all. Is that okay? So as I was saying, we cannot add or subtract this and this, so we will just write it as it is. Can we add our plus c? The answer is no. Why? Because this original integral is in x world, and these answers that we are having is in what? U world. These answers are the solution in the whole U world. We have to change it back to what? X world. And how are we going to do that? We can do that by replacing what we substituted this u for. So we are going to replace u with square root of 2x. Now let's replace it. The other one was the answer in the u world. This one here is the answer in the x world, and as you can see, it matches this original one here. So guys, the answer to this integral problem that we started solving is equal to this one here. Let's add our plus c to complete everything. Therefore, this one is equal to the whole of this one plus c. This c here means we are done with the integration, and it is what? Indefinite integral. Yeah, it wasn't easy, but we've tried. We've managed to gotten our answer at the end of the day, and I hope you guys are not confused and okay with the solution. Yeah, I know you have gotten to know other ways of approaching an integral question. You remember some parts we have to rewrite something as this plus this. They are all part of the journey. Yeah, they are all part of the journey. Sometimes you have to apply the idea of other field to help you in whatever that you are doing. And I hope you guys are okay now, and I hope you understand. You have found you have understood what everything. But well, if you have any question, you don't worry. You do your possible best to leave in the comment section, and I'll also try and give you your hot answer. Okay, it's cool. Yeah. If you are thinking of or if you are doubting this solution, you can try differentiating this whole answer here, and you can try differentiating this whole answer here to find out if you are going to get this one back. I'm not saying we are going to do it, but if you want to do it, you can. And maybe if you get stuck, you can let me know in the comment section, and then I will sort you out. Okay, so you just try differentiating the whole of this to find out if you can get this one back. Okay, all right, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching, and I will see you in another video. Bye.